All right, I made one video on the distance formula. I'm going to make this one to sort of tie it together and sort of show you how it sort of ties in with slope and things of that nature, and so how we can sort of visualize and draw the distance formula in sort of a different way. Um, so we know from the very first video that we did the distance formula, the distance between 2 points on a coordinate plane. Let me just get my pen here. Okay, it's a big square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So here we want to try to find a segment of length GH. Okay. So um, G we're going to use, we have 7, 0. H we have -10, -3. Okay. I'm going to draw this up and do this a little bit differently. Okay. So G is at 7, 0 right there. There's G. H is at -10, -3, so it's down here. All right, so there's our line segment. Now, I want to look at this formula here because this formula actually translates into something else that we did, okay? And it translates sort of with this, it sort of takes a slope formula and sort of combines the slope formula and the Pythagorean theorem, okay? So if we use the slope formula, remember the slope formula uh, y2 minus y1 over x2 minus x1, okay? Well, the y2 minus y1, again, we talked about that. That's just the rise, and the x2 minus x1 is just the run, okay? So we could take the rise and the run. Well, look at what we have here. So in the distance formula here, we have x2 minus x1 and then y2 minus y1 in there, okay? So really, we could sort of change the distance formula if you want to do it in more of a visual way, okay? Instead of x2 minus x1 squared, we could call that the rise squared, or the run squared, excuse me, run squared. The y2 minus y1, really, the rise squared, okay? So if we were to visualize this bad boy here, we can find our rise, we can find our run. And with the rise and the run, we create a right triangle out of that line right there, okay? So we have our run, we have our run, and we have our rise. So our run, we go from -10 to 7, okay, which should be 17. And whether you get a positive 17 or a negative 17 in there, it doesn't really matter because when we square it, it just becomes positive anyway. We see our rise go from -3 to 0, 3. All right. So let's think about this. Our rise is 3, our run is 17. Okay. So we'll do 17 squared plus 3 squared. So -17 squared is 289. 3 squared is 9. Right? So our distance is going to be the square roots of 298. Okay. Now, again, if we were to talk about this in a right triangle Pythagorean theorem kind of way, so we have our line right there from G to H. All we got to do is make a right triangle out of it by doing the rise and the run. The rise and the run are the two legs. Okay. And so we get, if we were to do it that way, we'd get, okay, 3 squared plus 17 squared equals c squared because it's a right triangle, Pythagorean theorem, right? So we get 9 plus 289, and we square root it. So we square root 9 plus 289, which is 298. Okay. And so that would be our answer, square root of 298. So the distance formula is really just the Pythagorean theorem sort of in disguise. Okay. And root 298 does not, I believe, divide into any perfect squares. So we can't simplify it any more than that. So distance would be root 298. Okay. So that's another way we can do the distance formula and visualize it and make it a little bit simpler, because I know that the formula itself is kind of big and scary a little bit. So we can draw these things up and do it from a right triangle Pythagorean theorem standpoint that way. Okay. So that's that for the remainder of 2C. And we should be able to knock out these distances right there. There's a distance formula calculator link right there if you want to use that link to check your work. Okay, I wouldn't use it to do the work, but use it to check the work and make sure your answer is good to go. Okay, and that'll be it. And y'all have a good day.